Calculate the left endpoint and the right endpoint L6 and R6. Then calculate the midpoint sum M6 for the function f of x equals x to the negative 1 power on the interval 2 to 4. We actually don't need the graph because we simply find the Riemann sum, not the area. The Riemann sum is the signed area, so when we set up the sum, the sign will take care of themselves. But we will need to figure out the left, the right endpoint, and the midpoint. The interval is from 2 to 4, with the left endpoint being 2 and the right endpoint being 4. We're using n equals 6 subinterval in this case, so the width of each of the subinterval or the rectangle is delta x. Delta x is b minus a over n. In this case, it is 2 over 6 or 1 over 3. We then divide or partition this interval into 6 subintervals. Each of these subintervals has a width of 1 over 3. We then turn a into a number with denominator 3. 2 is 6 over 3. Each of the subinterval has a width delta x of 1/3, so we can simply add 1/3 to 6 over 3 to get 7 over 3, 8 over 3, 9 over 3, 10 over 3, 11 over 3, and 12 over 3. Yes, 12 over 3 is 4. 9 over 3 is 3. And again, 12 over 3 is 4. So the left endpoint that we will use are 2, 7 over 3, 8 over 3, 9 over 3, 10 over 3, 11 over 3. 6 left endpoints. The corresponding right endpoints start with 7 over 3 all the way to 12 over 3. And if we want to use the midpoint, we would need to average the two. Taking the left endpoint of the first interval, 6 over 3, add to the right endpoint of the first interval, 7 over 3, and take half of it to find the midpoint. This is a half of 13 over 3, which is 13 over 6. The first midpoint is therefore 13 over 6. We then take this 13 over 6 and add 1 over 3 each time. But 1 over 3 is 2 over 6. So the next midpoint is 13 over 6 plus 2 over 6, which is 15 over 6. The next midpoint is 17 over 6. The next midpoint is 19 over 6. The next midpoint is 21 over 6. And the last midpoint is 23 over 6. And so now we have all of the midpoints and all of the left endpoints and the right endpoint. We can now set up the sum. L6 is, since all of the rectangles have the same width, we can simply factor out the width, which is 1 over 3. And then we simply add the height only. The first rectangle has an area of the width 1/3 times the height, but the height is the reciprocal. And so the height is 1 over x. If x is 6 over 3, then the height is 3 over 6. If x is 7 over 3, the height is 3 over 7. If x is 8 over 3, then the height is 3 over 8. And we would need to have 6 terms because we're using n equals 6. The next one is 3 over 9. The next height is 3 over 10. And the next height is 3 over 11. And we stop here. Again, the height is the reciprocal 1 over x. We will use a calculator to evaluate the sum, but we will need to set up everything so that we can use the calculator at once. R6 is, the first area is 1/3 times the height, but all of these have the same width, so we can factor out 1/3. The first height that we're using is the right endpoint, And with x equals 7 over 3, the height is 1 over 7 over 3, which is 3 over 7. The next height is 3 over 8. The next height is 3 over 9, 3 over 10, 3 over 11, and the last height using the right endpoint is 3 over 12. And so we still have 6 terms inside the sum. Double check that we have 1, 2, 3, 4, 5, 6. Width times height, width times height, width times height. Using the midpoint M6, the width is still 1 over 3. And this time, the midpoint, the first one is 13 over 6, so that the height is 6 over 13. The next midpoint is 15 over 6, so the height is 6 over 15. The next one is 6 over 17, 6 over 19, 6 over 21, but this is only 5 terms there. We will need one more term, 6 over 23. We can now use a calculator to approximate these. L6, if we put it in the calculator, we will get 0.737. That is the left sum. R6 is 0.653 using a calculator, and the midpoint is approximately 0.692. It is always the case that the midpoint is much more accurate. Usually, we average the two left and right sum, but even so, the average is still not good at the midpoint.